Well, hello everybody. So as promised, I'm going to show you how to make some smoke with fire, and all that using Vanilla Cinema 4D without any plugins. It's going to be Team Render safe, so you can actually render it on your network of computers, thousands of them if you need to. But anyway, it's going to be relatively fast to render anyway. So yeah, my actual how to create terribly fake smoke in Cinema 4D out of the box version. So without further ado, let's dive into Cinema 4D. So as I usually do, I want to set up my layout so it's easier for me to work. So let me go and first of all, I'm going to create a sphere and make it 20 centimeters. I'm going to use this as my emitter and press C to make it editable. And now that I have this, I'm going to add my Espresso tag here, and now I have this window, and I'm going to drag this window and put it over here. Fantastic. And the next thing I need to do is, you see these gray bars? These are the safe frames, and they annoy the heck out of me. So go to Options, Configure All, and somewhere here in the view, I'm going to get rid of the safe frames. Fantastic. And at the same time, I'm going to go to my filter and get rid of my, it's called the horizon. So now it's a nice clean view where we can view whatever we want without any distractions. Excellent. A couple more things I want to add to the interface are, let's go to Simulate, Thinking Particles Settings, drag this little guy down here, and finally go to Script, Console, and grab the console and put it here. So we have everything here, consoles, particles, materials, blah, 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 and all that. Excellent. So we are going to begin the particle emission using a P matter wave. So matter waves, P matter waves. And the reason is it's going to allow me to emit from an object. So drag the sphere here. I'm going to call this emitter. And I'm going to turn it off from visibility and render and just press play, and you can see we have particles going everywhere. So go to the P matter waves and do the following thing. I want the particles to be born without any speed. So I'm going to put this to 0, rewind, press play, and you'll see that just particles are generated on the sphere, nothing more. They're not moving because I'm going to use some secondary action to move them around. And I think this looks good. Let me see my count. I'm going to set it to 50, and I think these are enough particles to get us started. So rewind. Now let's add some sort of upwards motion, some buoyancy, and I'm going to use this node called pwind, and I'm going to connect it to the output particles. So you can see again we don't have any legends for our inputs and outputs. So basically we need to right click here, and I always do this mistake. I need to right click here and go ports and show names. So particles, we need to tell thinking particles which particles we want affected by the wind. And you know what I'm going to do? I'm just going to use the emitter itself. And if I press play, you'll see everything is going to move towards the plus Z. And to make it a bit more prominent, I'm going to set this number, the strength, to 2,500. I'm going to set the decay to 500, because if I don't, these are going to accelerate, whereas decay actually stops the acceleration at a certain point. And you can see that they're going that way. All I have to do is take the emitter, and with my rotation tool, I'm going to rotate it to point upwards, press shift to quantize it, and there you go. I have these particles going upwards from the surface of the sphere. Let's see if we need to change something. Now you can see they're going straight up, and I need to add some turbulence here. 500 seems to work nicely, and I'm going to change the frequency to 5. So this now creates a bit of turbulence. I'm going to extend my timeline to 250, and something like that happens sometimes. Good, and there you go. So we have some sort of undulation between these particles. Now, if you're wondering why I don't make them fly out even more, and that is because as the particles are growing in age, they'll get bigger as well. So the plume will grow by the size of each placard, each of the single planes. So I'm not going to worry about this too much. If I need to tweak it, I can go later on and touch upon the turbulence. Okay, so let's Command double click to make this a bit smaller, put it all up here, and let's continue. Now, the next thing I want to do is add some sort of a change of color to the particles, which will be relating to the age of each particle. So first of all, because I'm going to do some troubleshooting, I'm going to find my printer console, which is just for you that don't watch all my tutorials, although I should punish you. Just go to your system presets, go to the string, and just go printer console. And I just need this here, so if I need to print any data out in the console, I can actually do it. So let's check something out. I want to make the color of the particles follow the age of each particle. Now, before I do that, I just want to go here and change the life variation. So select the P matter waves, and I want about a 15% difference, so they don't all die right at 90 frames of life expectancy, but around 90 frames. Good. So now I'm going to add a P pass. P space pass. There you go. And I'm going to go through all my particles, and what I'm going to do is get some data from them actually, P get data. So I'm going to get, what data do I need? Well, I need the actual age of a particle. So I'm going to click here and get the age. Command double click, and I want to print this age. So I'm going to stop my simulation and put this in here and just nudge a frame forward. And you will see that the age is from close to 0, which is 0.033, is actually 1 frame worth of age in seconds, because we are at 30 frames per second. Go watch my videos. But you can see that the oldest one is around 3 seconds. Now, I want to set the color of the particles, and normally the color is a 3-part number. It's called a vector 3, which has components for the red, green, and blue, RGB, and each of these numbers can have a value from 0 to 1. Don't be confused about all the color models we have from 0 to 255 and all that. When we're dealing with the Espresso data for color, it's actually a vector 3, so 3 numbers, that each number can have a value from 0 to 1, where 0 is nothing and 1 is full. So I want to color them grayscale, which means that if I put a single number in the color, that will actually make them from black to white, or vice versa. But you can see that my largest number is 2.9 or 3, and it's not 1. I need to find a way to get a what we call normalized number. So I want this number to be generated by Espresso, and I always need it to be in a range of 0 to 1. And the easiest way to do this is as follows. I'm going to add the life. Because the life is the maximum time a particle can have, that means that if I divide the age by the life, that's going to give me the normalized number. So let me click here, and let's go to math, because we want to do a simple division. And I'm going to say, with a math selected, function divide. And I want to divide the first number with the second number. You can see the connections. Just going to make this a bit more compact, and maybe even drag this down to get a bit more room. Now if I put this in here and clear my console and nudge forward, you will see that all the numbers are from close to 0 all the way up to close to 1. So we have this normalized value, and that's fantastic, because now I can use that data to actually drive the color of the particles. So I need to set the data, and the particle we're going to set is the same particle we're actually getting the age and the life from, and the data we're going to drive, command double click here, is the color. So what this does, it says for the first particle, whoop, do the division and get the result, put it there. For the second particle, and it will go and loop, it will iterate, as we say, throughout all the particles. Excellent. Now if I rewind and press play, you will see that all the particles are white. And this is one of the very, very simple gotchas when we're using thinking particles. In order to visualize the color that's been set in our Espresso, we need to go to the Thinking Particle settings, select the group we're working with, and just turn off the use color. And unfortunately, it's a bit deceiving because use color, you would think we would use this color, but actually no, it pertains to use this color. I can go and change this to any color I want. And if I use that color, it's going to be green. If I don't, it's going to use the particle color. So all you have to do is bring up your Thinking Particle settings and select the group and uncheck the use color. Fantastic. So now you can see that we have these great little particles that as they grow older, they become white. Now here's one weird thing. You can see that we get these flashes here. And these flashes are because when we generate a particle, by default, the color is set to 1. It has some sort of color. So it generates particles which are white, and immediately after, when it goes to the next frame, it changes the color to whatever the age is. So I want to make sure these flashes don't happen. And in order to do that, I'm going to do it in a very simple manner. I'm going to just command and drag this to make a copy. And I want for every particle that is born, I want to set this color to black. So I'm going to set the actual parameter upon birth to be consistent with the lowest age, which is 0, which is color black. So in order to drive the color parameter with a number which is constant across the whole calculation, I need a constant. Constant. I'm going to put it here. I'm going to set this to 0, which is the default value. And now you can see we don't get the flashes anymore. So we have this great setup, and I'm going to save to make sure that we don't lose anything. With the file magically saved through the power of editing, let's continue and see what else do we need to do now. So we've got the color set. So let's go and use these particles in the MoGraph context so we can see what happens. So let's go and create a cloner. Let's tell the cloner to be in object mode. When in object mode, drag the particular group you need in here as the generator. Good. Now let's go and create a plane. Let's set the subdivisions to 1 and 1, and let's make it a child of the cloner. And you can see now we have a huge amount of planes here. And if I rewind and press play, you will see a stack of papers. You can use this to make stacks of papers. Excellent. So that's number 1. Now if you select the cloner, what you will see when you have a particle group selected is that we have these settings here, the velocity and the particle scale. We're not going to deal with the velocity right now. We are going to deal with the particle scale. So the developers of MoGraph made a very explicit control so that the particle scale, which is one of the many things a particle has, particle scale parameter, it allows MoGraph to read that data. Now, if you're wondering why don't we have controls for everything else, well, that was a decision they made when they were creating MoGraph, but I'm going to show you a way you can use to actually map any of the particle data to any other parameter in MoGraph. And this is a big part of this tutorial. So let's continue. So I'm going to leave this open for now, and I'm going to go to the particle scale and do this. Okay, so by default, when we generate an object, it has a size which is 10 and all that. And I think if I make this 100, now they're going to be in their actual size. I'm going to leave this default. Don't worry about it. And we are just going to play around with the scale and some range mappers to control the size of our placards. Okay, excellent. Now, let's see what else we need. Let's select this. And what we see here is, first of all, that these placards are facing upwards. I want them to face the camera all the time. So what I'm going to do is, with the cloner selected, I'm going to go and create a target effector. And in the effector tab, I'm going to go to look at camera. So now they're facing the camera. And of course, you're going to be like, ooh, but we can't see them and all that. Well, that is because by default, a plane is facing in the plus y direction. And as we all know, and if you don't, you ought to, the direction of view when we are using target or when we are using align to spline, the direction of motion or the direction that things face is the plus z or minus z for that matter. So now, regardless of where I view this from, these placards are going to face the camera all the time. So let's make it a bit fancy here, and let me double click and create a material. Let's call this smoke-ish anyway. Double click here, and let's just do a few things. Go to reflectance, actually delete reflectance, go to transparency, remove these. Let's add a gradient in here, and let's click on this and make it circular. I'm going to grab this and put it over here and turn on my transparency, and I'll have a slightly better view. Now you can see that the gradient is clipping, and this is something you must always remember. Select the knot and make sure that it's at 60%. That's the point where it won't clip. Now let's go and add 25% turbulence. Let's go and add some frequency here. I think 5 will do it. And make sure that in the editor you have animate preview, so you can actually see these buggers animating. And you can see now these little clouds. Excellent. Now the thing which is obvious at this point is that although we've activated the scale, we don't get any scaling. And that is a very simple thing to resolve. Just add a scale parameter. Now this scale parameter needs to be sort of equivalent of our color. So what I'm going to do is put this in here, and you can see immediately that we get this wonderful flashing, and then these grow older. And the reason again is because when they are generated, they are at the default scale. So what do? Well, we add the scale parameter here. Command double click to expand this and connect it here, and now everything is fine. Now there's one little problem here, that I want to control the size of the initial puff and the size of the final puff, and currently it's from 0 to 1. The easiest way to do this is to create a range mapper. So range, put it here, and I'm just going to put the output here, and instead of driving the scale directly, I'm going to drive it through the range mapper. By default, the range mapper maps 0 to 1 to 0 to 1, so it's as if it doesn't exist. But what I can do here is say that I want the initial size to be 2, actually the initial scale, and the final one to be 5. So with these two numbers, I can control the initial size of my puff, scaling actually, and the final scale of my puff. And that looks quite interesting. So I'm going to add a light just to make things a bit more nice. Put this here, render this. Ooh, fantastic. We'll find out why this is happening. So there you go. Got these nice puffs here. And let me select this and see what's the problem. Maybe the plane needs to be the -z. No, actually that's not the problem. This is the first thing this has happened to me. So, oh yeah, right. This is one of those things which may happen to you. So because the placards are facing me, and let's select this and add a camera so you can see where the camera is facing from. You can see the light is behind them. There you go. So these are one of the things that can get you, like it just got me for 3 seconds, but because I'm awesome and very knowledgeable and extremely smart, good-looking, tall, anyway, and many other things, and very modest for that matter, I know how to troubleshoot it in 3 seconds, and you get a very valuable lesson about how to set up Cinema 4D scenes. Let's select the light, go to General, and add some soft shadows. Render this just to get a bit of darkness, and don't forget, because we're rendering quite a lot of let's say overlapping transparencies, go to the render settings and make sure in the options that your ray depth is 60 is a number I found that is okay for this. You can always turn it down if you see that your render goes too slow, but look at this. This is not bad. Excellent. Let's render. Not bad at all. I'm quite happy with this result. Let me save this and let's continue. Now, the problem we are facing right at this moment is that the puffs, and please focus on the top. Right, look at the puff. Look at this one, which is the largest one. In a couple of frames, it's going to disappear. It's going to go pop, and it's out of existence. Now, that is not ideal because smoke fades away. It just doesn't pop away. And we need to find a way to propagate, to move the particle color data into the MoGraph context. And here is the big lesson of today. We are going to do this by using a surrogate. And the surrogate is actually a MoGraph weight. So do that, and you can see that when you click here, you've actually created a MoGraph weight. I'm going to go and clear it, although I don't need to do that. And I want to find a way to drive the data of this MoGraph weight map from the data in my Espresso. And mind you, this tip was given to me by Yader, and he's one of the smartest people I know. Even by my standards, he's like really, really smart. And that's a problem. I know too many smart people. Anyway, so full credits to him. I'm going to link down in the description with where you can find his videos and so forth. So let's do this, okay? Let's do this. Now, I'm going to right-click, and when you go to New Node, you'll find the motion graphics. This pertains to MoGraph. And first of all, I need to do the following thing. I need to get a MoGraph weight, and the MoGraph weight needs drag the weight in here, go to the object, command double click so you can see what it says, and just drag this where it says MoGraph weight. Okay, fantastic. Now, here's something that is a bit tricky, but it's a great thing to know. The PPass node or anything that generates particles has something called an index. If we want the IDs of the particles to match the IDs of MoGraph, then don't use the particle index to drive the MoGraph index. All you have to do is drive it directly from the particle output. This will filter out any redundant information and will drive the index of the MoGraph weight. And when we say index, is each of these points will coincide with one of the clones we have created, so one of the puffs. So what I've done here is I've connected my MoGraph weight to the PPass so that I can drive each particle at the same loop I'm using to define the color and the scale, and I'm telling the MoGraph weight to write the data over here, and we're going to use it in a certain context in a bit. The next thing I want to do is tell it what value to write there, and these are the only inputs it has. Nothing else makes sense. And the value I'm going to put in here is actually the output of this, that division, that normalized number. Now, if I rewind and press play, we should see the colors change. And you can see that they start red, which is 0, and end at orange, which is yellow, which is 1. But we see some sort of recycling going on here. So red, 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 and they become orange. No, I think everything looks pretty okay. And I want to try something. I'm going to go and take this and put it over here and stop this. Let's see if we need to do some troubleshooting. I'm going to advance by 1. So it's 0 to 1. So now we need to find a way to transfer the data from the weight map onto the color of the cloner. Just to experiment, I'm going to double click and create a new material. I'm going to go here and add a luminance channel, and in the luminance channel I'm going to add a MoGraph color shader, and I'm going to drag this on top of this. So I want to see very clearly what the colors are going to be doing. So in order to do this, I need to attach a plane effector to the cloner. I'm going to get rid of all the parameters. I'm going to set the color to user defined. Let's make it black. And now the most important part to make it work, I need to tell the plane effector to use the data from this selection. And voila! Now you can see that my placards are actually being colorized by the color shader in this material by their age, essentially, because the age is what defines what's going on. Excellent. So all I have to do is remove this material from here, remove it from here, and I'm going to go to my actual material. Let's stop this for a second and go to the alpha channel. I can add it as a layer of the transparency. I'm going to just put it in separate channel. I'm going to go here and add my MoGraph color shader, and you can see now that the top smoke fades out. And let's press play, and you will see that as it goes upwards, it fades out. And that's fantastic. Now, watch this. I'm going to go and zoom in here because we need to do one more adjustment. You can see that these puffs just spontaneously appear. So we've solved the problem of having the puffs fade when they are at the top, but we haven't solved the problem of having the puffs enter in a more civilized manner. So let me select my camera again to go to the other view. The easiest way to do this is to go and control this value with a range mapper so that it's transparent when they begin and transparent when they die. So let's create a range mapper, or copy this one, and I'm going to make sure that this one is 0 to 1, so it matches 1 to 1, or just delete it and create a new one if you're not sure, and use this output and put this in the value. So in theory nothing will change now, because if you go to the range mapper and you right click here and you say reset, you're going to see the way the values are mapped, which is in a linear fashion. I'm going to command click here to add a point, and what I'm going to do is raise this, and now you can see that they are entering from transparent to fully opaque, and suddenly they're going to start fading out. And if I click here and then press Command A to select all the points, and then right click and say, let's go to the point ease, easy ease, I can create a nice little slope. I can Command click here to make the top ones fade out a bit later, so you can play around with this and make it fade out in any way you want. But now you can see that the big thing is that the puffs are seen in a more sort of gradient way, so they don't pop into existence, they just slowly fade in. Good. Now let's go and solve one more problem, which is the repetitiveness. And you can see that this is the same puff that just gets bigger. So this creates some visual artifacts and makes it look repetitive. And in order to fix that, we're going to go to the cloner, and we are going to go and add a random effector. Good. And in the parameters, we're going to delete everything else, and we're going to go to the rotation and find which rotation is the best one. So I'm going to go here and add some rotation, and now you will see that the puffs have some sort of randomness in their rotation. There you go. So our smoke is finished. Let me save. And the final thing is to actually create some sort of fire glow here. And I'm going to do this by adding a light. I'm going to call this fire. I'm going to set the color to be a nice orange, and I'm going to set the fall off to be inverse square. Make this something like 50 or even a bit more. And if I render, you will see that we get some of these puffs lit up, but nothing really strong. So go to your material, and if it doesn't work the first time you click, just click again. Go to the luminance channel and add what is called a backlight. Leave it in its default state, and now this is going to catch light from everywhere. So let's save again, rewind, press play, and here we have an interesting fire and smoke configuration. Again, if you see a few repetitions, just go to your random effector and change the value. Let's make it 30. You can pretty much see a good preview there. Rewind, press play, and now it's more random. That looks fantastic. I really like this technique. Excellent. So the final part of this tutorial, and sorry for taking so long, but it was packed with knowledge, is how do we render this on a render farm? Now, depending on what sort of turbulence you have and all that, you will find that if you just go ahead and render this on your network, you're going to have jumps, because each computer is going to start the particle simulation from a different part. And the good thing is that there's a very, very, very simple solution to this. And that solution is to cache the MoGraph. So go here, right-click, go to MoGraph tags, add a MoGraph cache, and bake it. It's not going to take a long time, and now you can actually scrub through it. You can turn off your thinking particles if you wish, but everything has been written to a cache. And I'm going to render this scene, which I'm going to provide to you for experimentation and so forth. The only thing I'm not going to include is the caching itself, because it makes the file a bit bigger. It's 5 megabytes currently. So let me render this on my render farm, and I'll get back to you after that. And with the magic of editing, we're back to see the final render. It took a few minutes, I think 5 minutes to finish. And watch this. Now, it's playing, and I'd like you to observe these lines here. And this is something that happens sometimes with these things, and a lot of people get frustrated as to how to correct them. So let's go back here again, and you can see we get these flashes over here, these lines that come on and off. There's a very simple solution to that, and that is the following. Select your main scene light, and instead of soft shadows we had that creates those artifacts, turn this to ray traced hard shadows. Now, just an explanation, the soft shadows don't calculate the shadows by ray tracing. They take a snapshot of the light's point of view towards the objects and create some sort of mask, let's call it that way, and they apply some sort of blurring and so forth. And from frame to frame, this can create some odd results and create the flashes. But if we turn this to hard, then the shadows are actually ray traced, as it says here, and the result is the following. Here's the file. Let's press play, and you can see that everything is smooth as butter. We have the smoke fading up there, we have the fire, and you can put some objects here like wood or whatever you want this to burn. And this pretty much concludes this tutorial. And although it may seem a bit too complicated, it is something that works right out of the box. It will allow you to create these smoke and fire effects for background elements and so forth. You can create very stylized things because instead of a smoke effect, you can use all sorts of stylized graphics, which makes it ideal for motion graphics. And just make sure that you take care of your shadowing and all that, so you don't get the flickering. And also don't forget to cache the MoGraph animation. And if you do any changes to any particle motion, make sure to delete the cache before you recache again. Otherwise you'll make changes in the particles and the MoGraph cloners, but they won't actually work because the cache takes precedence over any changes you make. So just select the tag, delete it, do the changes, and so forth. So I hope you enjoyed this long-ish tutorial, and I'd love to see what you make with it or not. But anyway, please post any questions on Twitter or on my YouTube discussion underneath this video, and yeah, ask for more tutorials and we'll see what we'll do. And don't forget, follow the BroGraph guys, follow 3D Fluff, follow Cineversity, follow Insidium, and so many other great plugin creators and tutorial makers out there. And once again, toodaloo.